Bohdi Park, NEET and G Academy. Your dream, our mission.
Hello everyone. So welcome to this session of physics in which we are going to discuss 10 MCQs from the chapter Kinematics or the motion along a straight line and specifically distance and displacement. So welcome to Bohdi Park NEET and G Academy. Download the app and get access to various study materials. The link is given in the description. So let's start with the first question. Look at this first question. Location of a particle is changed. What can we say about displacement and distance covered by particle? Location is changed. So suppose this is a map and some particular object is here at A at some point of time. At some other time it is at B. So location on the map changed. So we can say the position also changed. Suppose this is the fixed point, this is the fixed observer. According to fixed observer, the point or the object shifted from A to B. So position changed. Location is changed. So there is a displacement. So we know that change in position is displacement. So position changed, so displacement is non-zero, and also depending on the route followed or the path followed, distance is also non-zero. Maybe it is a straight line or semicircle or any different route. So distance is also non-zero, displacement also non-zero. So both are non-zero. So both cannot be zero. Finished. Okay. Now next. Now question number 2. You look at this graph. The graph is of velocity and time. Okay. In the given graph, velocity time graph, which of the following quantity changes their sign? Which quantity changes their sign? Plus to minus or minus to plus? So clearly, if we consider this velocity, you see 0 to t1, between 0 to t1, velocity is positive, and t1 to t2, velocity is negative. 0 to t1 velocity positive, t1 to t2 velocity negative. So velocity changed its direction. Now if we talk about displacement, so 0 to t1 displacement is positive. Displacement means the area under this graph. Okay, when we calculate the area, we get displacement. This area, and we calculate displacement for t1 to t2, so you have to consider this area, it is negative. Okay, so 0 to t1 displacement positive, t1 to t2 displacement negative. So both 1 and 2, both displacement and velocity change the direction. Done. Now next question. Now question number 3. The position time graph is given for two children A and B returning from their school O to their homes P and Q respectively. So this is the position time graph for two students or two persons. Choose the incorrect statement. Position time graph is given, so the slope is velocity. Slope of position time is velocity. So which has more slope? Clearly we can check A and B. The slope of A is less, slope of B is more. Slope of B is more than slope of A. So velocity of B is more than velocity of A. So this one information we are getting. So B is walking faster. B walks faster. Okay. So third is wrong. We got the answer. Okay. Let's check few more options. A lives closer to school than B. So basically we can check the displacement. If you observe, for example, in this graph, suppose this is 0 meter, O means 0 meter, and Q means say 10 kilometer, and P is say 5 kilometer. So the displacement for A and B, we will find displacement for A. So what is the displacement for A? It will be, it is going from 0 to 5 kilometer. So 5 kilometer. And displacement for B, it is going from 0 to 10 kilometer. So who is near, whose house is near school? A. Okay. So A lives closer to school than B. So that is true. A starts from the school earlier than B. Whose motion started earlier? As you can observe, for this t is equal to 0, the graph of A started, and after some time the graph of B started. So A starts from the school earlier than B. That is correct. Who is reaching home earlier, or they are reaching home at same time or different time? So clearly the motion, the graph is finishing. The graph is finishing for B earlier than Q. Okay. So for B, the graph is finishing here. For A, graph is finishing here. So their journey is finishing at different instants. Okay. So at different times. So fourth option is also true. So we have to select the incorrect one. So that is option number 3. Now next question. Now question number 4. So in this question, the graph is given xt graph, position time graph. We have to find for two objects A and B, relative velocity of B relative to A. So velocity of B relative to A. So the formula, what is the formula for this? The formula is velocity of B minus velocity of A. So now velocity of B means it is slope. So what is the slope for B? So calculate the slope for B. Slope for B is negative and slope for A is positive. So how to calculate slope? Now find out. So for A, you observe these 2 points. You see at t is equal to 0, x is equal to 10, okay, for A, and t is equal to 2, x is equal to 20. So we have velocity of A is equal to delta x by delta t. So 20 minus 10 by 2 minus 0. So 10 by 2 or 5. Okay. we are using the formula for velocity delta x by delta t, slope formula for position time graph. Okay, clear? Now for B we have t is equal to 0, x is 40, and for t is equal to 2, x is 20. So velocity of B is equal to 20 minus 40 by 2 minus 0. So minus 20 by 2 or minus 10. So velocity of B relative to A is minus 10 minus velocity of A, which is 5. So that is be minus 15 meter per second. So minus 15, the answer is first. Okay, minus 15 meter per second. That is the relative velocity. Okay, so finish. Next question. Now question number 5. So look at question number 5. A car is moving along a straight line OP. This is a straight line. Along this line the car is moving. It is going from O to Q, then Q to P. So basically O to P in 18 seconds. O to P in 18 seconds. Returns from P to Q in 6 seconds. O to Q, Q to P, total 18 seconds. Q to P 6 seconds and Q to O 10 seconds. Which of the following is correct regarding motion of the car? Okay, so we have to find average speed of the car going from O to P and come back to Q is 20 meter per second. Okay, basically total journey, entire journey. So let's check the first. So for entire journey O to P and back to Q. So for entire journey 0 to 360, distance covered 360, then again going back. So 360. So distance is 360 plus 360 and total time 18 plus 6 plus 10. 18 plus 6 plus 10. So 360 into 2 by 18 plus 16, so that is 34. So this is 360 by 17. So this is not looking like it is 20. So first is wrong. Now average velocity of the car in going from O to P and come back to O. Average velocity of the car going from O to P and come back to Q is 20. O to P and P to Q. So displacement O to P displacement is 360 and then P to Q displacement is, you check what is the difference. This difference is 120. So 120 left. So minus 120. So displacement O to P and P to Q, the displacement is 240 meter. Now divide this by time taken. So we'll get average velocity displacement by time. So 240 by time taken. Now time taken from O to P and P to Q. Time taken O to P is 18, P to Q is 6, so 24. So this is 10. So second option is also wrong. Okay. Now come to third. Average speed of the car in going from O to P and come back to O. O to P and come back to O. So that is O to P and come back to O. So that we have found actually. Okay, first option actually that is third option. Okay, this is the third option. Okay, this is the third option we are checking. So that is not 20. Okay, so third option is wrong. Okay, let's check the first option again. Average speed of car O to P and up to Q. Okay, for third option, the distance covered for third option, distance covered is 360. Now back to Q. So P to Q it is 120. So 360 plus 120 and time taken 18 plus 6. So 18 plus 6. Now this is 20, correct. So first option is wrong and the third option is third option is wrong and first option is correct. Okay, first option is correct. O to P and come back to Q, that is correct. Okay, so that is our answer. Okay, so now we can check the fourth also. Average velocity of car going from O to P and come back to O. So O to P and P to O, displacement is 0. So average velocity is 0. So fourth option also wrong. So our answer is first. That's it. Now next question. Now look at this question. A body moving along a straight line travels 1/4 of distance, total distance, with a speed 3 meters per second. The remaining distance is covered with a speed 4 meters per second. For half the time and 5 meters per second for the other half time. What is the average speed for entire journey? So let's draw the diagram. Suppose this is the total route or distance or total path followed. We have to divide this route into two parts. One is 1/4, other is remaining distance. So let's take total distance is 4x. So the 1/4 is x and remaining is 3x. So this 1/4, that is A to B, it is taking 3, the speed is 3 meters per second, A to B. So we can calculate time taken from A to B. Time taken is equal to distance upon speed. So x by 3. So time taken from A to B. Now B to C, we have to consider total time divided by 2. Okay, two time intervals we have to consider, equal time intervals. So suppose B to C total time is 2t. Then there is a point D in between. B to D time taken is t, D to C time taken is also t. And B to D, the speed is given as 4 meters per second. And D to C it is given 5 meters per second. So we will calculate the distance now. So what is the distance covered for B to D? 4t. And what is the distance covered from D to C? 5t. That is equal to 9t. So 9t is equal to 3x. So we get t is equal to 3x by 9 or x by 3. So A to B time taken is x by 3. B to C time taken is 2t and t is x by 3. So what is the time taken from B to C? 2x by 3. So total time is equal to x by 3 plus 2t and t is x by 3. So 2x by 3. So that is equal to 3x by 3 or x. Total time is x. And what is the total distance? 4x. So average speed for entire journey, is equal to total distance by total time. So 4x by total time, which is x. So we get 4. Answer is 4. Done. Now next question. Now this question, a boy walks on a straight road from his home to a market 2.5 kilometer with a speed 5 kilometer per hour. Finding the market close, he instantly turns and walk back with speed 7.5 kilometer per hour. What is the average speed and average velocity of boy between 0 to 50 minutes? So we have to draw the diagram for such type of question. So let's consider home. This is home and this is market. Now home to market is 2.5 kilometer. So when it is going home to market, it is going with 5 kilometer per hour. So time taken we can calculate. Time is equal to distance by speed. So 0.5 hour. So that is 30 minutes. 30 minutes. Home to market 30 minutes. When returning, its speed is 7.5 kilometer per hour. We have to find average velocity for 0 to 50 minutes. So remaining time is 20 minutes. So for 20 minutes, it is going backside with speed 7.5 kilometer per hour. So we can find the distance or the displacement we can find. So displacement or we can say distance also. Left side it is going. Distance is equal to speed into time. 20 minutes into hour is 1 by 3 hour. So that is 2.5 kilometer. So now we can check. So in 20 minutes it will reach home because the distance is 2.5. Okay. So basically 2.5 kilometer right side and 2.5 kilometer left side. So total displacement is 0. So average velocity is 0 and average speed we can find using total distance by total time. Total distance by total time. So that is equal to total distance is 2.5 plus 2.5 and total time is 50 minutes. So 50 minute means 1 by 60. Hour. So that is equal to 5 by 5 and the 6 will go to the numerator. So 6. Average speed is 6 and average velocity 0. So 6 0. So second option is correct. Okay. So that's it. Now let's move on to next question. The displacement time graph of a moving object is a straight line. then we have to select the option. So displacement time graph is a straight line. So suppose this is the displacement time graph. So slope is constant. So xt graph, slope is velocity. Velocity is constant means acceleration 0. Acceleration 0, it is uniform motion. Velocity constant means uniform motion. So velocity is a uniform. Acceleration 0. So second option is correct because confirm acceleration is 0. So third is wrong, and both velocity and acceleration may be uniform. Yes, true. Acceleration 0 is also constant, so it is not very correct. Okay, so better option is second option. Now next question. Ninth question. So if the displacement of an object is 0, then what can we say about distance covered? Displacement is 0. Displacement is 0. Suppose A to B, particle is going A to B, then coming back from B to A. So displacement is 0. So distance is not 0. Distance is not 0. And suppose particle does not travel at all, particle is not moving at all, then distance is 0. So distance can be 0 or can be positive. It cannot be negative. Must be 0? No, it can be non-zero also. It cannot be 0. It can be 0 if particle not traveled. It may or may not be 0. So fourth option correct. Okay. Now next question. Now this question, a body makes a displacement of 4 meter due east from point O. Okay. So there is a point O over here, 4 meter east, and then makes 3 meter north. Its resultant displacement from O. So this is the initial position and this is the final position. So this will be the resultant displacement. So directly we can use the Pythagoras theorem. Okay, so this will be square root of 4 square plus 3 square, and that is equal to 5. So third option. That's all. Thank you.